Hello students, nice to see you guys. Let's get started. This is 8th grade math, unit 1, lesson 6, describing transformations. Let me help you with your work. The directions say, here is trapezoid A in the coordinate plane. Using the y-axis as the line of reflection, draw the image of A and label it polygon B. Okay, we're using the y-axis. So let me highlight that here. This is our line of reflection. We're drawing the image of A. That means A after reflecting across the y-axis. Then we'll label it polygon B. We can choose to use the drawing tool or Geogebra tools. Which do you want? Let's first try the drawing tools. So I'm going to get the line segment. When I reflect across the y-axis, I know that my points just move over across the line of reflection. All of the lengths stay the same. I can visualize what the image of A will look like. Now, let me connect those lines using the line segment tool. I've got a little mistake right here. Let me move that over. Ta-da! Okay, good. There, I got it. And it said to label that B. So I'll use the pen and we'll label that B. Okay, good. I did it. Let's keep going. The next set of directions are hard to find, but it's underneath the graph. On the applet above, that means going back up. On the applet above, draw polygon C, which is the image of B, using the x-axis as the line of reflection. Okay, so now we're going to use the x-axis as the line of reflection. So I'll highlight that in green. And we're drawing the image of B. So if I look at these points and go straight across my line of reflection, I can draw right about here. This side is 3 units, so this side is 3 units. Remember, all of the lengths stay the same. There's the image of B. The directions told me draw polygon C, the image of B. So I'm going to label that C. Let me use the Geogebra line segment tool to make it look a little cleaner. Here is the image of B, polygon C. I'll label that C. Okay, good job, guys. Let's keep reading. The next set of directions say, on the applet above, draw polygon D, the image of C using the x-axis as the line of reflection. Draw polygon D, the image of C using the x-axis as the line of reflection. Okay, so our line of reflection is still the x-axis. And we are reflecting C back again. So that's just going to go right back here. D is on top of polygon B. So how can I draw that with these Geogebra tools? I think just like this. I'll just label here that this is also D. Okay, good. I'll type that in on here. Polygon D is on top of polygon B. Okay, keep going. Next, the point -4, 1 is rotated 180 degrees counterclockwise using center -3, 0. What are the coordinates of the image? Let's try to visualize that. I'll draw a coordinate plane here. It says the point -4, 1. So that's going to be about right here. -4, 1. Now, if it is rotated 180 degrees counterclockwise using center -3, 0, -3, 0 would be about right here. Then it's going to be on this line right here. What are the coordinates of the image? Well, it's going to go over right about here. I can sort of visualize that. So the y-axis is going to become a -1, and the x-axis is going to become a -2. I can visualize that. Can you visualize that? Okay, go ahead and try it yourself. Try to visualize that. And then check your answer. Let's keep going. Describe a sequence of transformations for which triangle D is the image of triangle A. We have to just think about this and type in our answer. Okay, a series of transformations. Well, I think I'll start with a reflection across this line. And that line's coordinates are, just imagine these coordinates here, -1, 3, and -4. Oops, sorry, -1, -4. Remember the x coordinate, I better remember, the x coordinate comes before the y coordinate. Okay, so I'm going to have a reflection across the line. Let me type that in. And the line is with coordinates -1, 3, and -1, -4. I better write that a little clearer. Reflection across the line containing points. There we go. So what will it look like after that reflection? Let me draw that in a different color so we can visualize it. It's going to look like this. There we go. So what can I do next to go from my image over here to B? How about a translation from point 1, 2, coordinates 1, 2, translation to point 5, 4. Let me type in my answer. Now you could do this many ways. So you can use a different sequence than me, but think about it and make sure it works. Translation from point. When you describe a translation, you have to tell the beginning point and the ending point. So my beginning point is 1, 2, and my ending point is 5, 4. X coordinate 5, Y coordinate 4. Okay, there's my answer. Let's keep going. The next direction says, draw the image of quadrilateral ABCD after a translation that takes B to D. Okay, after a translation that takes B to D, can you imagine what this image is going to look like? I can. I'm getting pretty good at this stuff. I can imagine it's going to look something like that. Let's try using the Geogebra tools now. I wonder if we can get these to work. Okay, so we want the Translate by Vector tool, but first we must draw the vector from B to D. Then click the Translate by Vector tool, click the polygon, and then click the line. It did not work. Let me try that again. I'm going to just undo that. Okay, let me try again. Translate by vector. Click the polygon. Oh no, it keeps putting a point down. Okay, here's what we need to do. We need to draw the polygon. Here's the polygon. Let's just draw it right on top here. Okay, now we can do it. Now click Translate by Vector, click the polygon, click the line, ding. Okay, cool. You might need to watch that again. Remember, I had to go back and draw the polygon first, then draw the vector. Then I could do the translation. The next instruction says, draw the image of quadrilateral ABCD after a rotation about point A by angle DAB. Okay, here is angle DAB, but I don't know what angle that is. Draw the image of quadrilateral ABCD after a rotation about point A, so I'm going to circle A, by angle DAB. Okay, if I go by angle DAB, then I can know for sure, or I can imagine, and I'm sure of it, that line segment AD is going to end up right here. Then, if so, I can imagine what my shape looks like. Like that. I can try to imagine what my shape looks like. There, something like that. Let's use the tools to help. So, I'm going to use my polygon tool first to draw the polygon. That way the whole polygon rotates at the same time. Then, rotate around point tool, click the polygon, and click the point. Now, I don't know what angle that is. I'm just going to take a guess. 80 degrees? I'm not sure. I'm just guessing. Look at that. It's close. It went a little too far because line segment A prime D prime is not on line segment AB. So that was a little too far. Let me try it again. I have to start over and draw my polygon because I deleted too much. Okay, there. Rotate around point, click the figure, click the point. Now before I tried 80 and it was a little too much, so let me try 78 degrees. Ding! Okay, that looks good to me. I like that. Now let me erase my drawing. Still looks like it's a little bit too far, but close enough for me. So remember what we did. We rotated around center point E, and we rotated this angle right here from AD to AB. Let's keep going. Draw the image of quadrilateral ABCD after a reflection over segment BC. Okay, so segment BC is our line of reflection. Well, I can imagine what this will look like after a reflection over this line. Something like that. I can imagine. imagine that. Now let me try using these Geogebra tools to get it exactly right. I'm going to draw the polygon first. There, otherwise I would be reflecting it line by line. And then choose Reflect About Line. Click the polygon and carefully click the line. Ding! There's my reflection. Okay, good, I got it. Oh, this one looks hard. Let's do it together. It says, Andre performs a 90-degree counterclockwise rotation of polygon P and gets polygon P prime. But he does not say what the center of rotation is. Can you find the center? Okay, so a 90-degree counterclockwise rotation of P, that means going this way from P to P prime. What is the center of rotation? Well, they give us a few GeoGebra tools to help us figure it out. What if I draw a line segment right, right here? Okay, if I rotate 90 degrees, would it point over to my other corner? Let me try. I'm going to click the line, then click the point, and draw in 90 degrees. Oh, that's too far. That is not my center of rotation. Okay, what about... let me get rid of that. How about if we move the center here? I have to click the move tool. That was why it wasn't moving. Okay, let's try the center here. Rotate around point. I'm going to click the figure. Nope, I can't click the figure. Okay, click the line. Click the point. 90 degrees. It's getting close, but not quite. Okay, I'm not sure if that tool is helping me. I'm just trying to guess and play around. Okay, I need to use my pencil. Okay, if I'm going to visualize this a little easier, I need to find a point that is the equal distance from each of these. Oh, well how about this? This point here is 2 spaces away from that corner and 2 spaces away from this corner. Those are corresponding points. This corner and this corner are corresponding points, and they are equal distance to this point. Could that be the center of rotation? Let me test it with another point. From here down, I better change my color. From here down, this goes 1, 2, 3, 4 spaces down, 2 spaces over. Let's see if that works the other direction. 2 and 4. 2 spaces, 4 spaces. That means this is an equal distance and this is an equal distance. I think I found it. Now how can we test it with GeoGebra tools? Let's use the line segment and draw our line from here to here. And that's convenient. It goes right along polygon P. Then rotate about a point. Click. Oops, I didn't click the line. Let me do that carefully. Click the line and then click the point. Put in 90 degrees. Ding! Phew! I got it. That was a close one. Okay, did you see what I was doing? Just trial and error to figure it out. Now it's your turn. Go to your assignment and see if you can figure it out. Bye-bye.